So here we're looking to determine the force of the seat of the Ferris wheel on Georgia at the top of the ride and the bottom of the ride. So we know the mass of Georgia, and we know the radius of the Ferris wheel and the time it takes to make one complete rotation. So at the top, to find the direction of the acceleration, we have our final velocity, which is drawn in red on the diagram, minus our initial velocity, and our change in velocity would be pointing down, which means our acceleration is also pointing in the same direction. At the bottom, you have your final velocity plus your negative initial velocity, so subtract it from it, and the change in velocity is pointing up. Okay, in determining the speed, right, we have a Ferris wheel traveling in a circle, so the distance here would be the circumference, so 2 pi r divided by the time. So this is going to be 2 pi r times 10 meters divided by 15 seconds. And ultimately, that would be approximately 4.2 meters per second. So that would be the speed of the coaster. Or it's not the coaster, the Ferris wheel. All right, now we're going to draw some force diagrams. So we are sitting upright in the seat. So at the top here, we are going to be looking at the force of the seat. And that is going to be smaller than the force of the Earth because our acceleration is pointing down. At the bottom, we have the Earth, which is the same amount as it was originally because the mass of the person does not change. But the seat is going to be larger because the acceleration is pointing up. So setting up Newton's second law, at the bottom, we are going to have the force of the seat minus mg over the mass is equal to our circular acceleration, so v squared over r. And then to solve for the force exerted by the seat, it is going to equal mv squared divided by r plus mg. And when I substitute all those numbers in, v squared over r is going to be 1.75 meters per second squared. So when you multiply by that mass, you get 105 plus 600 newtons. So the force exerted by the seat is going to be 105 newtons. Or sorry, not 105 newtons, 705 newtons on Georgia. Now at the bottom, okay, we have the force of this. We have the force of the seat pointing up. So I'm going to call, since my acceleration is pointing down, I'm going to call down positive. So the seat will be negative plus mg over m is equal to v squared over r. All right, so in determining the force exerted by the seat here, I will have the force exerted by the seat is equal to mg minus mv squared over r. And we're going to have 600 newtons minus 105 newtons. That will equal 495 newtons. So the force of the seat will be